If you want to calculate mole fraction of B, it can be calculated using formula NB divided by Na plus NB. How can you calculate molarity of the solution? Molarity of the solution is calculated by using expression WB divided by MB into 1000 divided by V. Why A represents solvent means when you are preparing solution, first we have to take solvent, to that we have to add solute. Therefore, the part 1 is solvent, part 2 is solute. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. I already discussed the first session of solution chapter. In that, I discussed about what is solution, and two important terms of solution are solute and solvent, and types of solutions. In types of solutions, I discussed about 3 types of solution like solid solutions, liquid solution as well as gaseous solution. And I discussed about concentration. In the concentration are expressed in many ways. First one is mass percentage, second one is volume percentage, third one is mass by volume percentage, fourth one is parts per million, that is ppm. Fifth one is mole fraction. In the first session, I had given introduction about solution. What is solution, my dear student? Homogeneous mixture of 2 or more substances is called as solution. In solution, we have 2 parts. One is solute, other one is solvent. And how much solute is dissolved in given quantity of a solvent or given quantity of a solution is called as concentration. Concentration can be expressed in many ways. The first 5 units I discussed in the first session. The first one is mass percentage, second one is volume percentage, third one is mass by volume percentage, parts per million, fifth one is mole fraction. Today, in the second session, I am going to discuss about 3 more units which are used to express concentration. First one molarity, second one molality, third one normality. What are the 3 important units? First one molarity. Next one today I am going to discuss about, that is molality. Last one, that is normality. And I am going to discuss about few problems related with concentration. How concentration is calculated. Once again I will repeat, what is concentration? Concentration is the amount of solute dissolved in given quantity of solution. Now I am going to discuss a problem relating with mole fraction. Related with what? Mole fraction. Problem number 1. Calculate the mole fraction of ethylene glycol in a solution containing 20% of ethylene glycol by mass. 20% of ethylene glycol by mass. Okay, already I had given definition for mole fraction. Mole fraction of solution cannot be calculated. Mole fraction of each component can be calculated. If I consider a solution containing 2 components, A and B, mole fraction of A is calculated as well as mole fraction of B is calculated. Mole fraction of A is calculated as Na divided by Na plus Nb. Na divided by Na plus Nb. Mole fraction of B is calculated as Nb divided by Na plus Nb. Na divided by Na plus Nb as well as Xb is equal to Nb divided by Na plus Nb. What is N? N stands for number of moles. N stands for number of moles. And how can you calculate number of moles? Number of moles is calculated by using formula N is equal to W by M. What is W? W is given mass. W is given mass. M is molecular mass. M is equal to molecular mass. Again, number of moles is equal to W by M. It is a very important key point to calculate number of moles in your competitive exams also. How do you calculate number of moles? Number of moles are calculated by using formula. Once again I will write N is equal to W by M. What is W? W is given mass. W is given mass. M is equal to molecular mass. M is equal to molecular mass. Number of moles is equal to given mass divided by molecular mass. Mole fraction is denoted by capital X. Mole fraction is denoted by capital X. Mole fraction of solution cannot be calculated. Mole fraction of each component present in the solution can be calculated by using formula. Number of moles of that component divided by total number of moles of all the components present in the solution. Number of moles of that component divided by number of moles of all the components present in the solution. For example, if you want to calculate mole fraction of A, it can be calculated by using formula Na divided by Na plus Nb. If you want to calculate mole fraction of B, it can be calculated using formula Nb divided by Na plus Nb. Now, calculate the mole fraction of ethylene glycol. Ethylene glycol in a solution. Now, ethylene glycol is act as solute. In a solution, and it is prepared by solution. Ethylene glycol solution is prepared by using water. How much percentage? 20% of ethylene glycol. C2H6O2. C2H6O2. Okay. So, 20% of ethylene glycol means 20 gram of ethylene glycol. 20 gram of ethylene glycol present in 20 gram of ethylene glycol present in 100 gram of solution. Therefore, the weight of solute, that is ethylene glycol, is act as solute. Here A represents solvent. B represents solute. Why A represents solvent means when you are preparing solution, first you have to take solvent, to that you have to add solute. Therefore, the part 1 is solvent, part 2 is solute. A represents solvent, B represents solute. W is 20 gram. Solvent is water, that is WA is 100 minus 20 is equal to 80 gram, because it is how much percent solution? 20% solution. Next, molecular mass of B as well as molecular mass of A. Molecular mass of B means B is ethylene glycol. A is water. Already you know that molecular mass of it is water. So, water. Molecular mass of water is 18. As well as ethylene glycol. What's the formula of ethylene glycol? C2H6O2. To here 2 carbon, 2 into 12 atomic mass, 6 into 1 and 2 into 16. 24 plus 6 plus 32. It is equal to 62. Molecular mass of ethylene glycol 62. Molecular mass of ethylene glycol is 62. How can we get molecular mass? Molecular mass is obtained by adding atomic masses. For example, here 2 atoms of carbon are there. 2 into, what's the atomic mass of carbon? 12. Here 6 atoms of hydrogen. 6 into, what's the atomic mass of hydrogen? 1. Here 2 atoms of oxygen. 2 into atomic mass of oxygen is 16. So, 12 2s are 24, 6 1s are 6, 16 2s are 32. Totally, its weight is what? 62. What's the molecular mass of ethylene glycol? Molecular mass of ethylene glycol is 62. Water, every time no need to calculate its molecular mass. Remember, my dear student, the molecular mass of water is 80. Therefore, here solute is ethylene glycol, solvent is water. Therefore, WB is 20 gram, WA is 100 minus 20 is equal to 80 gram. Next, MB is ethylene glycol, 62, MA is water, A is water, that is 18. Now you should calculate the mole fraction of ethylene glycol. That means we have to calculate XB is equal to NB divided by Na plus NB. What is NB? NB is equal to WB divided by MB. What is Na? WA divided by MA. What is WB? WB is 20. MB is 62. What is WA? WA is 80. And what is MA? 18. That is 20 by 62 is equal to 0.322 mole. 0.322 mole. Next, 80 by, it is 4.444 mole. Now we have to calculate mole fraction of ethylene glycol. Ethylene glycol is a solute. It is considered as B. Therefore, what's the formula I had to put? XB is equal to NB divided by Na plus NB. NB divided by Na plus NB. What is NB? NB is 0.322. Na is 4.444 and NB is 0.322. Therefore, 0.322 divided by 4.44 plus 0.322 is equal to 4.76. Now 0.322 divided by 4.76 is equal to 0.067. 0.067. The mole fraction of ethylene glycol is 0.067. As you know, the mole fraction does not have any unit. The mole fraction does not have any unit because in the numerator also number of moles, denominator also number of mole, mole get cancelled. Therefore, mole fraction does not have any unit. This is how do you calculate mole fraction using formula XA is equal to NA divided by NA plus NB, XB is equal to NB divided by NA plus what? NB. Next problem, calculate the same mole fraction of benzene in solution containing 30% by mass of its carbon tetrachloride. Here they had given solvent is carbon tetrachloride. In the previous problem, they had not mentioned solvent means you have to consider as water. But here the solvent is carbon tetrachloride. Benzene is solute. Benzene is B component. Carbon tetrachloride is A component. So what's the mass of W? WB is 30 gram. WB is 30 gram. WA 30% means 100 minus 30 is equal to 70 gram. Calculate the mole fraction of benzene in solution containing 30% by mass of it in carbon tetrachloride. Benzene is solute. That's why you have to take B as component. Carbon tetrachloride is solvent. That's why it is taken as A. Solute is considered as B. Solvent is considered as A. Which is solute here? Solute is benzene. So what's the mass of solute B? That is 30 gram. What's the mass of solvent? It is 30% means 100 minus 30. So it is equal to 70 gram. Now I have to write MB and MA. What is MB? MB is molecular mass of B is solute, molecular mass of benzene. It is molecular mass of carbon tetrachloride. What's the formula of benzene? C6H6. Therefore, how do you calculate? 6 into 12 plus 1 into 6. So 72 plus 6, that is equal to 78. Okay. Molecular mass of carbon dioxide 1 into 12 plus 4 into 35.5. 12 ones are 12. 35.5 into 4 means 35.2 times means it will become 71. 71 plus 71, it is 142 and its mass is 154. CCl4 is what? 154. So we had WB 30 gram, WA 70 gram, MB is molecular mass of benzene 78 as well as molecular mass of carbon tetrachloride is 154. Now we have to calculate what is the mole fraction of benzene. What's the mole fraction of benzene? Benzene mole fraction, it's a solute. I have to take it as what? XB. XB is equal to NB divided by NA plus NB. NB divided by NA plus NB. You have to calculate NB as well as NA. What is NB? NB is WB divided by MB. It is WA divided by MA. So what is WB? What's the weight of solute? 30. What's the molecular mass? 78. It is WA is 70. What's the molecular mass? 154. 154. Therefore, you divide 30 by 78, which is equal to 0.384 mole. 0.384 mole. 70 by 154. 70 by 154. It is 0.454 mole. 0.5 NB as well as what? NA. So now you substitute here. NB is 0.384. NB is 0.384. NA is 0.454 plus NB is 0.384. 0.384 divided by 0.454 plus 0.384 is equal to 0.838. Now 0.384 divided by 0.838 is equal to 0.458. What's the mole fraction of? What's the mole fraction of benzene? Mole fraction of benzene is 0.458. It does not have any unit. For mole fraction, my dear student, don't write any unit. Don't write any unit for mole fraction. For mole fraction. Okay. Next unit, which is expressed molarity. It is denoted by capital M. What is molarity of the solution? Molarity of the solution, solute is expressed in terms of number of mole. Solution or solvent is taken in liter. It is taken in 1 liter. Therefore, what is molarity of the solution? Molarity of the solution is defined as, it is the number of moles of solute. It is the number of moles of solute present in or dissolved in 1 liter or 1000 ml or 1000 cm cube of the solution. 1 liter or 1000 cm cube of the solution. So, my dear students, once again I will repeat, what's the definition for molarity? Molarity is defined as number of moles of solute. Number of moles of solute present in 1 liter or 1000 cm cube of the solution is called as molarity. Therefore, molarity is equal to number of moles of solute divided by volume of the solution in liter. What's the formula one we can use for molarity? Number of moles of solute divided by volume of the solution. Number of moles of solute NB is given by WB divided by MB. What is W? W is given mass. W is given mass and M is molecular mass. M is molecular mass. Therefore, molarity is equal to WB divided by MB into 1000 divided by V. What's the expression for molarity? How one we can calculate molarity of the solution? Molarity of the solution is calculated by using expression molarity is equal to WB divided by MB into 1000 divided by V. What is that molarity? WB is mass of solute, MB is molar mass of solute, V is volume of the solution. So, molarity is expressed in unit mole per liter or mole per dm cube. Mole per liter or mole per dm cube. As well as in molarity expression, you observe that volume is in the denominator. Therefore, molarity depends upon what? Temperature. So, how it is depends on? Molarity is inversely proportional to temperature. As molarity depends on temperature, as the temperature increases, molarity of the solution decreases because volume of the solution increases. Therefore, what's the unit for molarity, my dear student? Mole per liter. Mole per liter or mole per dm cube. Mole per liter or mole per dm cube. How can you calculate molarity of the solution? Molarity of the solution is calculated by using expression WB divided by MB into 1000 divided by V. What is W? W is the mass of the solute. What is MB? Molar mass of the solute. What is V? V is the volume of the solution. How it depends on temperature? Molarity is temperature dependent. As temperature increases, molarity decreases. As temperature increases, molarity decreases. Now, I am going to solve problem relating with molarity of the solution containing 5 gram of NaOH in 450 ml of solution. You have to calculate molarity of this solution. You have to calculate molarity of the solution. What is the solute? 5 gram of NaOH, 5 gram. That means WB is equal to 5 gram and MB is molar mass of NaOH. Molar mass of what? NaOH. That is 1 into atomic mass of Na is 23, 1 into atomic mass of oxygen 16, 1 into atomic mass of hydrogen. It is equal to 40. It is equal to 40. V is equal to 450 ml. V is equal to 450. My dear student, remember some of the important molecules, molecular mass. For example, if in the exam, if it gives sodium hydroxide, what's the molecular mass of sodium hydroxide? 40. Now you have to calculate molarity. Now you have to calculate molarity. Molarity is equal to WB divided by MB into 1000 divided by V. What is WB? WB is 5, MB is 40 into 1000 divided by what? 450. So if you calculate 5 into 1000, 5 into 1000, 5000. So now 5 into 1000, it is 5000. 5000 divided by 40 into 450. 18,000. 5,000 divided by 18,000. It is equal to 0.277. What's the unit for molarity? Mole per liter. What's the unit for molarity? Mole per liter. Okay. So calculate the molarity of the solution. Okay. Next, calculate the molarity of each of the solution. First one, 30 gram of problem A. 30 gram of cobalt nitrate, 6 water. First I'll calculate its molecular mass. Cobalt is 58.7 atomic mass. Nitrate is 14. Oxygen is 16. 16 3s are 48. 48 plus 48 it is. So NO3 twice means nitrogen is 14. Oxygen is 16 3s are. So 16 3s are 48. 48 plus 14. So it is equal to 2. It is nothing but what? 62. 62 2s are, it is 124. It is 124. As you know that water is 18. 18 6 are. 6 into, so 8 6 are 48. 48 4. So it is 108. 108. If you add this 58.7 plus 124 plus 108 equal to 290.7. Equal to 290.7. It is a molecular mass of cobalt nitrate, that is MB. It is MB. And WB is 30 gram. WB is 30 gram. And it is 4.3 liter solution means it's in liter. We have to convert into, V is 4.3 liter. We have to convert into ml. It is 4300 ml. It is 4300 ml. Therefore, what is the mass of cobalt nitrate hexahydrate? 30 gram. 30 gram. What is its molecular mass? 290.7. Therefore, what's the formula for molarity? Formula for molarity is equal to WB divided by MB into 1000 divided by V. What is WB? WB is 30. MB is 290.7. 290.7. 1000 divided by 4300 ml. 4300 ml. If you simplify this, 30. 2 zeros are cancelled. 30 into 10, it is 300 divided by 290.7 into 43. 43. This is 12500.1. Now it is 300 divided by 12,500 is equal to 0.024. 0.02 molar. 0.02 molar. This is how do you calculate the molarity of the solution. How do you calculate molarity of the solution? Molarity of the solution is calculated by using formula WB divided by MB into 1000 divided by V. Into 1000 divided by V. Okay. So now you will get the molarity. Second part, you have to calculate the molarity of 30 ml of 0.5 molar H2SO4 diluted to 500 ml. So M1V1 is equal to M2V2. That is before dilution and after dilution. Before dilution and what? After dilution. Before dilution and what? After dilution. Okay. So you have to find out. So M1 into 500. M2 is 0.024 into 30 into 30. M1 is equal to 0.024 into 30 divided by 500. Divided by 500. 0.24 into 30 divided by 500. It is equal to 0.00144. 0.00144. It's a molarity. It's a molarity after dilution. After dilution. Next, What is molality? What's the difference between molarity and molality? Both molarity and molality, solute should be taken in terms of number of moles. But in case of molarity, it must be in liter. In case of molality, it must be in kg. What is molality? The number of moles of solute dissolved in 1 kg or 1000 gram of molality. Therefore, molality is equal to number of moles of solute divided by mass of the solvent in kg. So, molality is equal to same WB divided by MB into 1000 divided by WA. What is WB? WB is the mass of the solute, MB is the molar mass of the solute, WA is the mass of solvent, WA is mass of the solvent. Molality is independent on temperature because its mass is independent of temperature. Mass is independent of temperature. Agar what's the formula to calculate molality? Molality is calculated by WB divided by MB into 1000 divided by WA. Instead of V, we have here WA. This is molality. Okay. You have to calculate molality of 2.5 gram of ethanoic acid in 75 gram of benzene. So, here ethanoic acid is solute, therefore B, benzene is solvent, it is taken as A. So, what is WB? WB is 2.5 gram, WA is 75 gram, MA, that is molecular mass of benzene. Observe here, calculate the molality of 2.5 gram of ethanoic acid. Ethanoic acid means acetic acid in 75 gram of benzene. In 75 gram of benzene. What's the formula to calculate molality? Molality is WB divided by MB into 1000 divided by WA. What is WB? WB is 2.5 into 1000. What is WA? WA is 75 gram. What is MB? MB is molecular mass of B. B is acetic acid. Molecular mass of acetic acid is 60. Molecular mass of acetic acid is 60. Therefore, when you calculate, it is 2.5 into 1000 is equal to 2500 divided by 60 into 75. 4500. This is cancelled. 25 divided by 45 is equal to 0.355. 0.355. What's the unit of molality? Mole per kg. Next concept, normality. So, normality represents number of equivalents of solute present in 1 liter of solution. It represents number of gram equivalents or number of equivalents of solute present in 1 liter of the solution. Normality is equal to number of equivalents of the solute divided by volume of solution in liter. So, therefore, normality is equal to WB into 1000 divided by E into V. Divided by E into V. Therefore, in today's class, I discussed about molarity, molality, normality as well as some problem. Therefore, my dear student, in this session, I discussed about molarity, normality as well as problem. Next session, I'll come up with new concept. That concept is what? Solubility. Until that, goodbye. Thank you.